on. All right. Five Nights at Freddy. Wow. So you do it all at once, Madison? Did you do it all at once? 5 nights, is that 10 hours? Or did they cut it down a little bit? Okay. How long did it last? All right, so for those people that came in late, do the pretest bonus real quick. You got 6 minutes, 2 o'clock, okay? 2 o'clock at the latest, 6 minutes, and I'll see who's in there. Let me do that. Let me go look in my over here and see who is involved in that. Tell me when you're done. All right, so I've got, let's see if there's anybody new today that's in there. Let me see. All right. All right. Nobody yet. Let's see here. Oh, thanks. Thanks. It's just not pulled back. Thanks so much. 6 hours. Wow. All right. So are you guys in there? You got 5 minutes to complete this 10-point bonus pre-test on ionic bonding. So you don't have to know anything about it. Just go ahead and do it, right? Go ahead and do it. All right. So who was the last one that did it last hour? Did I miss somebody yesterday last hour? Oh, let's see who we got. Oh, Jocelyn. Jocelyn did it. Is Jocelyn here? All right. Is Jocelyn? She's not even, she must have done it before she came. Okay. Jocelyn is one from our group. Hey, Madison. Saying you don't have access. Okay. So let me give you this link here just in case. Okay. Here you go. Try this. Okay. I might have had a problem with giving the wrong link. It happens to me sometimes. Let me double check. All right. That's block one. That says block 6. So anybody else having trouble getting in? Is to try and be better. So, that's why I need you to do a pretest stuff you don't know, and then hopefully we can get you to 80% or better. That's our goal anyway. Hey, all right. So what we're doing today, I can review valence electrons. So we've talked about valence electrons now for about a month. Lewis dot we haven't talked about for a couple of weeks. This is new. I can define ionic compound. I can determine what is needed for an ionic compound to form. So you shouldn't know anything about that. And I can understand the process. So using your notes, you should be able to do well. We've done that. So let's take an overall big picture look at this. All right. So chemical bonds, a big picture of this is you are bonding with electrons. Okay, so that's what we're doing. We're doing a chemical bond, and that's an attraction between two or more atoms that hold the atoms together. So we are talking about this today, and then next week, this is next week, and then this is the following week. These are the third week. So we're going to be talking about this and the ongoing, but we're going to use the periodic table a lot. We're going to figure out how to use that. So that's what we're doing today. So this is the key idea. You got a metal, so you got to know where it is. Remember, it's on the left side. Left side of the periodic table are all the metals. There are quite a few of them. So the interesting thing about that, they get rid of electrons. Why? Well, we'll tell you why. and nonmetals want more. So there's, well, it's kind of like, it's nice. They do something. Metals want to give up electrons, nonmetals want to take them. So here is a metal. Sodium, this is your metal, and chlorine is your nonmetal, right? And it always starts like this. You always have the metal first and the nonmetal. That's the way we do these things. Um, when we do ionic bonding, any kind of bonding, we always have one thing first over the other. So in ionic bonding, metal comes first, and then the nonmetal comes after that. So we're going to represent this as, and this is a review about Lewis dot structure. Remember, Lewis dot shows the number of valence electrons. Okay. Normally, so sodium has three shells because it's in the third period. So it has three shells, it has two in the first, 8 in the second, and then 1 in the third. Okay. But we use this Lewis dot, which is a lot easier than having to draw all these rings. Chlorine has 3 shells as well, but it has 7 valence electrons in the outer shell. So we can just show those and makes it a lot easier. Those are the bonding electrons. Those are the ones that make the difference. The other ones are shielded inside and they don't react with anything. It's the ones on the outside, the ones furthest away, that have the most energy for bonding. All right, so remember your groups. Group 1, the alkali metals, right? Alkali metals, right? And then group 2, alkaline earth metals. We're going to be talking about these alkaline. And then we've got your uh, uh, transition metals. Now we're not going to be talking about these because other than we know that they're transition metals, because these vary. All right, vary their valence. Okay, so this is alkaline, has 2 valence electrons. So 1, 2. Alkalis have 1. The row 13 has 3. 1, 2, 3. Row 14 has 4. 1, 2, 3, 4. Row 15 has 5. 1, 2, 3, 4, and we double up 5. Row 16 has 6. 1, 2, 3, 4, 5, 6. So we double up on a couple. And then row 17 has 7. 1, 2, 3, 4, 5, 6, 7. So we double up. And row 18 has 8, so it's full. These are not going to be the ones that react with anything. So no reaction. These are the noble gases. Remember, the noble gases are the ones that they don't want to talk to anybody. They're really snooty. Noble gases don't react with anybody. So that's how they work. Okay, so this tells you the structure on how to do the Lewis dot. I just kind of demonstrated it in the last slide, right? So first we'll back up a little bit and we'll talk about what an ion is. An ion is an atom that has lost or gained electrons and has a new charge of positive or negative. Remember, cations, right? Cations are the ones that are positive. Remember, we talked about cations because we have little cat over here, whiskers, right? Whiskers on its cute little pink nose, right? Because it has paws, you know, that's why we say it's positive, P-A-W-S, P-A-W. Okay, it's positive. It's lost an electron, lost electrons, because you can't lose. You can lose electrons or gain electrons, but you can't lose protons because it changes the elements. Anions, I think of a lot like an onion. Oh, they're not something you want to eat raw, right? Unless you have some salsa, right? So they are negatively charged. They gain electrons. They're looking for electrons, and they become ions. This becomes negative, and this becomes positive. Why does an atom lose or gain electrons? Because they want to be more stable. Okay, to have a complete outer shell. An outer shell can be 2 electrons or 8. If it gets to 2 or 8, it's stable. 2 or 8 is stable. Okay, so let's first of all find out where the metals are in group 1. Now, please do me a favor. Don't say hydrogen, okay? You see it's red. These are the non-metals over here. That's why they got them in red, non-metals in red, and the metals are all in blue. So we're looking for group 1. All right, so let's do a quick poll to see if anybody's here. My colleagues are telling me that nobody is, there's hardly any participation today. I'm not sure why. Name a group. I've been having pretty good participation. I don't know about them. Name a metal in group 1. Metal in group 1. Maybe, let's see, name a metal in group 1. Let's start a poll. So just use those 3 letters there. Come on, Oz, Bradley, Brent, Christian, Gavin, Jasmine, Jeremy, Khalees, Madison, Mariana, Rihanna. So we're looking, hey, there you go. Thanks, Bradley, Khalees. Thanks, Kamaya. You got it there, Jeremy. Let's see. Shayona. Yep, you got it. Zaria. Let's see. Zaria. Yep, yep. Okay, so you can use any of these right here. You could use this one. You could use this one. You could use this one. You could put K down. You could put RB, CS. You could put FR. Tanisha, Christian. Oh, you put 3, which is this. Okay, so you got to put the Li. That just tells me how many protons, right? So Li, right? So the number 3 tells me how many protons, right? That's great. That works the same. Okay. So you guys are doing better than all my other classes combined. All right, you guys did great. So lots of those. So that's the metal ones. These want to lose electrons. Lose. Okay, electrons. So losing electrons is what they want to do. So they want to lose electrons and become positive. Now that is the hardest thing for people to find to say here. Okay, so losing electrons, lose, hello, SE, lose E, makes them positive. Okay, so doing that because remember on the periodic table when the protons equal to electrons, when protons equal electrons, then it's a zero charge, zero. Okay, so if we think about that, it's like how we do this. We go 3 pluses and 3 minuses. Okay, they cancel each other out, right? Cancel each other out. So that is what happens. They cancel each other out. Oh, I see. It can't do that now. Okay. All right. I don't want to do that. Okay. So they cancel each other out. One goes to one goes to, so they come together as, but if you take one of those electrons away, right, you take one of those electrons away, all right, you got a positive charge, right? All right, so let's take a look at the non-metals. Okay, let's start another poll. Group 17 non-metal. What is, name a non-metal in group 17? Non-metal in group 17. Okay, so what are we looking at group 17? Remember, this is 18. Okay, all these are 18, so don't pick those. right? So let's what's a metal non-metal in group 17? What's a non-metal in group 17? Yeah, Br, F. Anything else? Br, F. Yep, a lot of Fs. Hopefully not a lot of F's in this class, as I'm hoping. Hey, thanks for that, acetine. Thanks, Gavin. Yeah, any one of these, F, Cl, Br, I, At, Ts. Excellent. Good job, guys. 17 out of 18. Okay, so those are the second part. The nonmetals, okay, are the second part, and they want to, let me do this. I want to get rid of this thing here. They want to gain electrons. Okay, so think about it again. So if we had um, something that has 1, 2, 3, 4. Let's do that again. Let's see. 1, 2, 3, 4 protons, and then 1, 2, 3, 4. Oops. Let's do this again. Okay. Not getting this. 1, 2, 3, 4, 5 electrons. When I want to cross those out, so 1, 2, 3, 4, 1, 2, 3, 4. I have an extra electron, so that makes it negative. Okay, makes it negative. Okay, it's the chemical bonds are called electrostatic forces between two oppositely charged ions, transfer of an electron from a negative charge to a positive charged molecule. So you can see what's happening here, right? You can see what's happening here. Electron, the sodium is getting rid, oops, I'm drawing, not, okay, so they're getting rid of an electron that's going over to the chlorine. Okay, it loses its shell, right? Now it has two shells. Cool, it's done. It's got 2 and 8. That is where that's stable. 2 and 8 is stable. And it becomes positively charged. Here it's 2, 8, and 8. It's happy. So these guys are really happy. This one is really happy as well. You transfer those electrons, and because of the charges here, they stick to each other like glue. They stick to each other like glue. Oppositely charged ions want to be neutral, so they are neutral overall, right? They're neutral overall because this positive cancels this, but that attraction between the two is that force between the two, or the intermolecular forces. I think I forgot to talk about that. Creates an attraction between two different elements called intermolecular forces. In between molecules. In between molecules, okay? Right? So in the molecule itself, okay? So there are collections of molecules. So if I had 2 sodium chloride atoms together, there would be molecular forces between the two of those, but inside the molecule itself is intermolecular. All right, so here's what happens, and this is kind of real slow motion here. This is the element potassium, there's the element fluorine, and we're bringing it closer until, wow, there we go. Okay, just as a quick poll here, guys, tell me, which is the metal? Which is the metal here? K or F? K or F? Remember, I said first comes first, K or F? Thank you very much, Soraya. You got it. Kamaya, you got it. Khalees, you got it. Shayona, good job. All right. Christian, you got it. Connor, great job. Yeah, it is the K. So potassium is the metal in this particular case. So what does the non-metal look like? Let's do this one. What's the non-metal? What is the non-metal of this? Yeah, that's it, Christian. Very good. F, right? Everybody's got it. You got it. It's 100%. 10 people, 100%. The F is the non-metal. It's on the right-hand side. The metal is on the left-hand side of the periodic table. Okay, oppositely charged ions attract each other. So that means that they stick together like glue. All right, so once the electrons are given to the other atom, the two electrons are attracted by the law of opposites. Law of opposites, opposites attract. Yes, it's a law. Two opposite charges uh, will attract each other, and that is how they're stuck together. So after the bonding, ions will be stable. Once they want to do this, they don't like them being by themselves. They want to bond with something else. Before the bonding, they are unstable. And stable means if they are stable already, like the noble gases, right? The noble gases, they don't want to bond at all. Noble gases don't bond. They don't bond. All right, so they are already stable. So let's take a look at the properties of ionic compounds. They conduct electricity when molten or in a solution, high melting point and boiling point, form crystalline structures. So they're they have a shape like a cube, that kind of stuff. They look like this. Here's a crystalline structure. Um, Ionic compounds are held together by attraction of oppositely charged cations and anions. Ionic compounds dissolve in water and conduct electricity. You can see the anions are the negatively charged. In this particular case, it would be like we were talking about chlorine and sodium and chlorine. The anions are the positively charged, and those are the metals and the nonmetals attracting each other. So there is at least 6 other neighbors that are pulling each other tight in arrangement of atoms and molecules for the crystalline structure. Okay? Okay. So your W11 assignment 1, okay, you can do this. Um, use the notes. Use the notes. Let me change that to something that looks a little bit bigger here. Use the notes. Okay, so the notes for today, if you use the notes, it's pretty straightforward taking um, notes. Do this assignment in Module 11. Okay, so I'm giving you time to do that. Okay, I'm going to take people from this list. So this is how many people are missing W9 assignment 1. So you guys are the smallest group. So you have your choice. Okay, I'll tell you this. Okay, you have your choice. I'm going to work with people in the breakout room. I'm going to pull people in here. So let me give you this. I'm going to go to the modules. And if your name is on that list, you have a choice. You could come in and work with me. Certainly a lot easier to work with me. I give you 15 points. Or you can do this by yourself this time. So here, let me give you this. All right. Here is, and it's pretty fun to do. It's a quizzes assignment. You can do this as many times as you want. I'm also going to do a quizzes assignment, but I'm going to walk you through it. So this is W9 assignment 1. Okay, W9 assignment 1. Right? Do it yourself, or I will pull you in. So if you're going to do it yourself, fine, but let me know. Okay, so I'm pausing this. Anybody get that assignment done that I can cross your name off? Let me know in the, I can also double check. I will unlock. I also cross those out for tomorrow. So not everybody was here. So I'll do this again tomorrow for some people that weren't here. Okay. So you guys are free to go. Have a good day. I will see you tomorrow.